Okay, then I can write pi is of course function of what? Function of space and the time. Right? That means I need coordinate. So I set a coordinate over here. Okay. If you like x, y, z. Then I can argue that this one has complex magnitude. This is complex magnitude. And then I can write, because this is a plane wave, I can write that this is j omega t, meaning that oscillating in time with the frequency omega. In other words, I assume that any incident field can be decomposed into many harmonically oscillating sound field. Okay? And then minus or plus, I don't know yet, but I can write that this is Ki dot R. Right? We learned that when we have plane wave, that means we have certain surface that is plane, right, with respect to the wave vector, that is K vector, right? And K, this is R vector, and KR dot means how many waves are really propagated in R direction, right? If we decompose this into xy coordinate, I can write that this is kxi x and ky I y in x direction and y direction. Okay? If you are not very comfortable to write a wave equation in terms of wave number vector and the position vector r, then you can use this notation until you feel comfortable to use k vector. But what essentially k vector dot product r means how many waves are really propagating in r direction, because dot product simply means the projected, the projection on r direction, k dot r, right? So what we are doing, I'm trying to express what we assumed to have physically in mathematics, because I want to use this mathematical expression to get out some unknown physical phenomena, which we normally call physical thinking or rational thinking. In fact, if you can do this kind of things very well, you can do anything. For example, economics or solid mechanics or fluid mechanics, whatever. Okay? Now, so this is what we can have. And then I can also write the reflected wave that has complex magnitude And by the same token, a similar idea. And also I can write PT so I have three different wave vector, KT, KR, KI, but all have the same frequency. This is because we are handling linear system. Okay? But note that the K, that is the magnitude of propagation vector, that is omega over C, and the C does depends on medium. So for medium 0, that is 0. Medium 1, that is 1. So immediately we can understand that there are two different type of wave number, K0 and K1. Yeah. Okay. In fact, you've learned you learned this kind of things in actually in elementary school. But we are just to try to express what we learned in all the days, mathematically express what we know, to explore some other things we do not know. Okay, the reason why we are trying these three P waves is because we know that those waves satisfy the governing equation, of course, right? We know that those satisfy right? That's why we are not solving governing equation. We just assume the three solutions that satisfy governing equation, and then rest of things is to find out the relation PI, PR, and PT that satisfy the boundary condition of flat surface of discontinuity. What is the boundary condition of flat surface of discontinuity? The guy who came here very late. What is the boundary condition of flat surface of discontinuity? What fluid has to satisfy on this surface? Velocity. Oh. What fluid has to satisfy on the flat surface of on the window then? When we have wave coming out from outside. Okay, as this guy just noted, the velocity has to be continuous and 정민 and angle? Pressure, magnitude. The pressure has to be continuous, as well as velocity has to continuous. Okay. That's a good point.